Hello, my dear friends. Welcome to the Sharpage update. Deepak Tiwari is here, and in this video, I will tell you how can we find the value of electric current in different parts of any electrical circuit with the help of Kirchhoff's law. So first of all, I am explaining the Kirchhoff's laws of current distribution. So friends, here I am explaining the Kirchhoff's laws for current distribution. Means Kirchhoff's laws for current distribution. Friends, in 1842, scientist Kirchhoff gave two laws for finding the distribution of current in different conductors in a complicated electrical circuits. The first law given by Kirchhoff is known as current Kirchhoff law. Means Kirchhoff's current law, KCL. And according to Kirchhoff's current law, the algebraic sum of all the current meeting at any junction in an electrical circuit is always equal to 0. It means in mathematical language, we can say that sigma I equal to 0. Here I am saying that the algebraic sum of all the currents meeting at any junction in an electrical circuit is 0. The direction of electrical currents which are coming towards the junction is taken as positive, and the currents which are going away from the junction are taken as negative. For example, A is a junction of any electrical circuit, and at this junction, suppose some currents are incoming currents and some currents are outgoing currents. You can see here the I1, I2, I3 are the incoming currents. Means I1, I2, I3 are the currents which are coming towards the junction, and I4, I5, I6, I7 are the current which are going away from the junction. So in this figure, at junction A, I1, I2, I3 can be taken as positive because they are coming towards the junction A, while I4, I5, I6 and I7 are taken as negative because they are going away from the junction. So in mathematical language, we can write here I1 plus I2 plus I3 minus I4 minus I5 minus I6 minus I7 equal to 0. Here you can see that I1, I2 and I3 are positive because they are incoming currents. I4, I5, I6, I7 are taken as negative because they are outgoing current or they are going away from the junction. In other words, say, we can write I1 plus I2 plus I3 equal to I4 plus I5 plus I6 plus I7. So you can see here the sum of all incoming currents is always equal to the sum of all the outgoing currents at any junction in any electrical circuit. So this is the Kirchhoff's current law. And remember, Kirchhoff's current law means Kirchhoff's first law of current distribution in any complicated electrical circuit is based on the conservation of charges. Now, Kirchhoff's second law. Kirchhoff's second law is also known as Kirchhoff's voltage law or you can see that KVL, Kirchhoff's voltage law. And according to this law, the algebraic sum of the products of electrical current and the corresponding resistance in different parts and the different electromotive force is always equal to 0 in any closed electrical circuit. And friends, the product of current and resistance is taken as positive in the direction of electric current, while the product of electric current and the resistance is taken as negative opposite to the direction of electric current. And friends, inside in a cell, in an electrolyte, the current when flowing from negative electrode to the positive electrode, then EMF is taken as negative. And while the current is from positive electrode to negative electrode, then the EMF is taken as positive. It means in going in an electrical circuit, if negative electrode comes first, then EMF means electromotive force can be taken as negative, and if the positive terminal comes first, then the EMF can be taken as positive. Here I am drawing a closed electrical circuit for explaining the KVL, means Kirchhoff's voltage law. So friends, now here, in closed electrical circuit A, C, D, B, A, according to the Kirchhoff's voltage law, as I have told you before, the algebraic sum of the product of electric current in different conductors and their corresponding resistance and the different electromotive force is always equal to 0. So, in closed circuit A, C, D, B, A, C, D, B, A. Then if the direction of electric current is in this way, means current is starting from here and is going in this direction. So according to the Kirchhoff's voltage law, in this closed electrical circuit, I1 into R, where R1 is the internal resistance of the cell of electromotive force E1. It means E1 is the electromotive force or EMF of this cell, and R2 is the internal resistance of the cell of EMF of E2, and R, capital R, is the external resistance. So in this closed electrical circuit A, C, D, B, A, according to the Kirchhoff's voltage law, I1 into R1, I1 into R1 minus I2 into R2 minus I2 into R2 minus E1 minus E2 minus E1 minus E2 equal to 0. Now you can see here I1 R1 minus I2 R2 minus E1 minus E2 equal to 0. In this closed circuit, you can see the direction of current in this way. I1 is in the direction of this electric current. So the product of I1 and R1 is taken as positive. Now you can see in this branch, the current is in this direction, but I2 is flowing in this direction. It means opposite to this direction. So the product of I2 and R2 is taken as negative. And you can see here, in this branch, the electric current is coming towards the negative electrode, and in this branch, the electrical current is coming towards the negative electrode, or you can see that the current is going from the negative electrode to the positive electrode, and in this branch the current is also going from negative electrode to the positive electrode. So the E1 and E2 is taken as negative. So in this closed circuit ACDVA, according to the Kirchhoff's voltage law, I1R1 minus I2R2 minus E1 minus E2 equal to 0. Now in this closed circuit, means in C, E, F, D, C. So in C, E, F, D, C. In closed circuit C, E, F, D, C. By Kirchhoff's voltage law, we can write. Now here in this closed circuit, the direction of current is in this way. So according to Kirchhoff's voltage law, the product of I2 and R2 can be taken as positive because I2 is flowing in the direction of electric current. So I2 into R2. Now you can see here the current I3 means equal to I1 plus I2 is also in the direction of this current. So the product of I3 into R, or you can see that, or you can say that the product of I1 plus I2 into R will be positive. So I2 into R2 plus I1 plus I2 into R, I1 plus I2 into R. And now you can see here that in this branch the current I2 is going from negative electrode to the positive electrode. So the EMF E2 will be negative. So minus E2 equal to 0. So this is the mathematical form for the electrical closed circuit C, E, F, D, C according to the Kirchhoff's voltage law. And now here you can see that at this point means at the junction C, by Kirchhoff's first law means Kirchhoff's current law, the value of current I3 equal to I1 plus I2, because I1 and I2 are the incoming current at junction C and I3 is outgoing current, and according to the Kirchhoff's current law, the sum of all incoming current is equal to the sum of all outgoing current. So I3 equal to I1 plus I2. Now by these equations, this and this, by these equations we can find the value of current distribution in each conductor, or you can say that in each branch of this electrical circuit. So this is the Kirchhoff's voltage law. Now friends, Kirchhoff's voltage law is based on the law of conservation of energy. So these two laws are the Kirchhoff's current distribution law, and with the help of these two laws we can find the current distribution in each branch of any closed electrical circuit. Now I am explaining an example based on Kirchhoff's current distribution law. Now friends, here we have to determine the electric current corresponding to the conductor AB, BC, AD, DC and BD. मीन्स हमें इस इलेक्ट्रिकल सर्किट में AB ब्रांच, BC, AD, DC and BD में इलेक्ट्रिकल करंट की वैल्यू फाइंड करना है with the help of Kirchhoff's laws for current distribution and the equivalent resistance between the A and C. So by using the Kirchhoff's laws of current distribution, we can find the value of electrical current in different conductors and the equivalent resistance between the A and C. So friends, first of all, we have to show the distribution of electric current in each or in every closed electrical circuit. Like the total current I is flowing through this cell of EMF of 2 volt. At this point, means at point A, the current is distributed in 2 parts. First part is represented by I1 and the second part is represented by I2. So I1 current is flowing through the AB and I2 current is flowing through AD. And at point B, the current is again divided into 2 parts. Like I3 current is flowing through BD. And now remaining current means I1 minus I3 is flowing through DC. Now at point D, the current I2 and I3 meets. So in this branch means in DC, the current flowing is I2 plus I3 and direction of this current is in this way. So this is the direction of the distribution of current in each branch of this electrical circuit. And here the total current again will I, and this is flowing in this direction. And the direction of current in this closed electrical circuit means A, B, D, A will be in this way, in this way. And the direction of electric current in this closed circuit is in this way, and the direction of closed circuit in this way. So these are the direction of electric current in this closed mesh or in this closed electrical circuit. This is the direction of current in this electrical circuit, closed electrical circuit, and this is the direction of this in A, D, C, A. So according to the Kirchhoff's current law, at the junction A, means according to the Kirchhoff's first law, I equal to I1 plus I2. So this is the equation number 1. Now in this closed mesh means A, B, D, B, in closed circuit A, B, D, A, B, D, A. By Kirchhoff's voltage law, the current I1 is in the main current, and here you can see that I3 is also in the direction of this current, but I2 is opposite to this current. So according to the Kirchhoff's voltage law, in this closed electrical circuit, I1 into 2, because the product of resistance and electrical current is I1 and the corresponding resistance is 2 ohm. Now you can see here plus 5 into I3, because I3 is flowing in the direction of this current, but I2 is flowing in the opposite direction to this current, so minus 3 I2, so minus 3 I2, 2 I1 plus 5 I3 minus 3 I2, but there is no EMF, so equal to 0. This is the equation number 2. Next, B, C, D, B. According to the Kirchhoff's voltage law, I1 minus I3 into 3, I1 minus I3 into 3. Because I1 minus I3 is in the direction of this current, and I2 plus I3 is opposite to the direction of this current. So minus I2 plus I3 into 2, because corresponding resistance is 2 ohm, and I3 is also is opposite to this current. So 5 into I3 minus 5 into I3 is equal to 0, because there is no EMF in this closed circuit. So this is equation number 3. And in this closed circuit A, B, C, A. So A, B, C, A. 3 into I2 means 3 I2. You can see there the I2 plus I3 means direction of I2 plus I3 is also in the direction of this current. So plus I2 plus I3 into 2. And the current is entering from the negative electrode. So the EMF is taken as negative. So minus 2 equal to 0. This is equation number 4. And if the equivalent resistance between the point A and C is capital R, then according to the Ohm's law, V equal to IR, V means EMF, EMF is 2 volts, so I means total electrical current, so I, and the total, or you can say that electrical, you can say that equivalent electrical resistance is R, then I into R equal to 2. So this is the equation number 5. So by equation 1, 2, 3, 4 and 5, we can find the value of current in different part of this electrical circuit. So this is the example of finding the electrical current in different parts of in any closed electrical circuit by using the Kirchhoff's voltage law and Kirchhoff's current law. So my dear friends, for more contents, please like and subscribe the channel, the Sharpage update. Till then, goodbye.